the variation of s is s xx equal to summation x square minus summation x whole square summation x whole square divided by s variance of sx. It means x square summation. How much we are coming? X we have to summation by square is x, then minus x, how much summation x whole square, total whole square, and then that sample size n. Then this result we have to deduct from here. This is the variance, that is x square summation x square. What is the difference in between this? This is summation x whole square under up to size. So this got one result. This one totally subtract from this one, but there is a difference, Here squaring x only. Here squaring summation x. So we have to deduct from this value from here. That one is the variance. Okay. And the covariance of x and y is, and the covariance of x and y is xxy. This is variance. Here covariance sxy. Here xx only. In between same xx only. So here sx, here same like this. Here only x into x square. Okay. And here that's why here put xx square. Here xy, this xy this xy is there, no? This one here minus ex summation x summation y divided by n. What is this difference? Here separate is the, no, that's why we are multiplying. Then divide by n. Then how much we got? We have to deduct from the summation xy. Okay, xy t here coming, here same x. So that's why x square, here x square, here xy separate. Summation x summation y summation xy. Yeah, always anywhere what we are getting, under how much that sample size only we are calculating. Okay, variance. Then the slope of a simple regression equation is, the slope of a simple regression equation is what? A equal to sxy by sxx, that is covariance divided by variance. What is the difference between covariance and variance? It is called regression, simple regression. Understand? And the intercept of a simple regression equation b equal to summation yn minus a summation x divided by n intercept. So intercept of a simple regression. So summation y, then n under n summation y, how much, then that is regression value into summation x divided by n. We got to, after multiplying, got this value, we have to subtract from here. Okay, this concept only. But we are deducting, multiplying this a with the x only. Okay. Why it is not? So same concept, deducting. Okay. So independent, we have to intercept of a simple regression equation. So summation y under n, summation x under n, then how much you are getting, multiply with a, then total value deduct from this value. It is called intercept of a simple regression equation. Independent and dependent variable. Variables can be either dependent if they represent an outcome of the study, or independent if they are presumed to influence the value of the dependent variables. Dependent variables, there is also a third category, control variables, which might influence the dependent variable but are not the main focus of interest. Okay, this line is important. For independent if they are presumed influence the value of the dependent variables. There is also third category, control variables, which might influence the dependent variable but are not the main focus of interest. Okay, in a standard linear model such as OLS, ordinary least squares, standard linear models such as ordinary least squares regression equation, the outcome dependent variable is indicated by y and the independent variables by x. The standard linear model such as ordinary least squares, for example, ordinary least square, regression OLS, regression equations, the outcome, for example, black box, the outcome depend on variables indicated by y and the independent variables by x. Y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus up to epsilon 1. epsilon. It means where epsilon means error. Epsilon error means error. And reflects the fact that we do not assume any regression equation will perfectly predict y, and theta are the regression coefficients. Theta are the regression coefficients. Okay, epsilon r means error, and it reflects the fact that we do not assume any regression equation will perfectly predict y. Perfectly predict y result. And betas are regression coefficients. Regression coefficients. So this is the output. So regression coefficients. Okay. Other terms used for the dependent variable include the outcome variable. Other terms used for the dependent variable includes outcome variable, the response variable, and the explained variable. Other names for independent variables are regressors, predictor variables, explanatory variables. Multiple linear regression. Multiple linear regression. Multiple linear regression may be used to find the relationship between single and continuous outcome variable and a set of predictor variables that might be continuous, dichotomous, or categorical. If categorical, the predictors must be recorded into set of dichotomous dummy variables. Multiple linear regression. Multiple linear regression is maybe used to find the relationship between single continuous outcome variable uh, and a set of predictor variables that might be continuous, dichotomous, or categorical. If categorical, the predictors must be recorded set into the set of dichotomous dummy variables. Multiple linear regression in which two or more independent variables predictors are related to a single dependent variables is much more common than a simple linear regression. Two general party principles apply to regression modeling. First, each variable included in the model should carry its own weight. It should explain unique variance in the outcome variables. Second, when you deal with the multiple predictors, you have to expect that some of them will be correlated with one another as well as with the dependent variable. That is, y equal to beta naught plus beta 1 x1 minus beta 2 x2 plus beta n xn plus epsilon. Y is the dependent variable and beta is the intercept. Beta naught is the no variable can be linear combination of other variables. Okay. So here in this figure here x1 x2 to x this is x value, this is here beta x1 beta naught x1 distribution of y1, distribution of y2, distribution of yn, regression